Hope everyone is cozying up at home, washing their hands regularly, and social distancing for sure. I myself am going to be dialing into this conference from my couch in my best pair of sweatpants and probably with an offensively large cup of tea. My name is Yuraima Estevez. I am a tech lead over at the New York Times. And today we're going to talk about some of my favorite topics: accessibility, testing, and automation, and how the three can connect together. As engineers, we've already embraced the practice of protecting ourselves from bugs by writing tests and cutting time in our development process through continuous integration and continuous development. And we can take those same practices and apply them to developing accessible sites and accessible apps. When we invest in testing and automating parts of our accessibility development, we save time and we build confidence in our systems that they will work for everyone and consequently make the web better for everyone. So today we're going to talk about how we can do good without doing anything. We're going to split this up into two parts. We're going to have some tooling where I'll talk about the automated tools I like to use at different stages of my development process. And this helps to automate the harder tasks that we often have to do manually to allow me to keep my code bases free of accessibility bugs. And then we'll also talk about testing. I'll cover the kinds of tests we have to write, what we want to validate when it comes to accessibility support, and the different strategies that we can take when we're designing our components and apps. So quick disclaimer, I primarily work in JavaScript and specifically in React on the front end. So a lot of my examples are probably going to be in React, but almost everything in this talk is agnostic of language, framework, and library. The implementation details will definitely be specific to your code bases, but you can use the types of tools and the strategies in this talk to help guide those decisions on how you can make a path forward for yourselves. So let's kick it off with some tools. The first one I want to share is called JSX Accessibility. And this one is probably the lowest lift, lowest effort for most people because it's an ESLint plugin. And a lot of folks already use linters in their development process. It's going to help us catch some common accessibility mistakes in our code while we're writing that code. And because it's automatable, we can tie into it in our Git hooks so that we can prevent inaccessible code from getting committed to our code bases. And we can also use it in our CI/CD pipelines to say, fail a build if it doesn't pass and prevent any accessibility issues from making it into our production environments. Our next tool is called Lighthouse. It's an open source automated tool for improving the quality of web pages. And the way we want to use it is to run accessibility audits on our websites. What's great about it is it comes in a lot of different flavors, but all of these do about the same thing. It just depends on how we want to use it based on our preferences and on our code bases. It comes automatically integrated into our Chrome DevTools. And that's great for me because I use Chrome every day in my development process, and I just get it for free. We can also use it in the command line to write different scripts against the node modules that we can include, and then consume the results in a way that will allow us to programmatically automate these tools into our development process. There's also a flavor of Lighthouse that allows us to integrate it into our continuous integration systems, and it's fairly configurable, but also can be used right out of the box. And the last one is a web UI, but that's probably the one we'll use least often. For now, let's take a look at Lighthouse in the Chrome DevTools. If we open up the DevTools, head over to the Audits tab, we're going to see a list of different audits that we can run and a couple of different options that we can set depending on our preferences. I happen to be an organizer of a meetup called Use React NYC, so I'm going to be using our website for the next demonstration. We can choose to run the accessibility audit, and then Lighthouse is going to give us a score out of 100. And this is going to let us know how accessible our website is by checking if we're adhering to accessibility standards and best practices. Along with that score, we're going to get a list of where we lose points and how we can fix these errors. So I generally like to run Lighthouse in the dev tools when I want to get a sense of a site's baseline accessibility score, or even as I'm making changes to my code to make sure that I'm not unintentionally degrading my accessibility support. Another perk of Lighthouse is that it gives us the option to run other audits, not just for accessibility. We can also run audits against our performance, best practices, SEO, and progressive web apps. And all of this is rolled into one tool so that we can make sure we're building a top quality site without a ton of additional work on our end. The next tool I want to talk about is called React Axe. And this is an open source tool, and it's going to allow us to test the accessibility of our React applications while also working in the Chrome DevTools console. For this demonstration, I'm just going to use the New York Times Wellness Challenge application and open up my dev console. And we're going to see that React Axe is already adding different messages to my console to let me know the accessibility errors that I have on my page. These messages include a severity rating with minor, moderate, or serious as a rating so that we know what category of error this is. And it gives us a helpful link to a resource that details what the error is and how we can fix it. This is similar to Lighthouse in that it's automated and it gives us the accessibility of our website, but it's very different in that Lighthouse is a static checker. It will only check your website on the page load. But as you see, for React Axe, as I'm moving through my website, I'm scrolling down, I'm clicking buttons, I'm moving pages, React Axe is updating with new errors that it's finding every time I interact and every time a component re-renders. And then finally, the last tool for today, Axe Core. This is a really powerful API for building and running automated accessibility tests. And actually, both Lighthouse and React Axe are powered by Axe Core at the foundational level. So in reality, you're already using Axe Core. It's just a matter of the tools that are built on top of it. So this would be a really great option if you need to do any kind of customized testing or really want to dig into the different kinds of APIs that you can leverage in your CI/CD pipelines or your development process. Now let's move on to testing. We want to add testing to our apps so that we can check the continued accessibility of our sites and applications. Another quick disclaimer for this, I'm going to share the tools that I like to use, but again, the frameworks and the libraries here don't matter. What we want to pay attention to is what I'm testing and why it's important to test them. We're going to cover the 3 kinds of tests, and these are the most common in accessibility. We want to test we want to make sure we're including unit tests, integration tests, and end-to-end tests. And we'll start off by talking about unit tests. We're going to be testing the individual standalone components so that we can validate our components' APIs and behavior. And generally, we want to be testing things like the ARIA attributes and whether or not they're present and what values they have in our components. And if our component supports keyboard navigation, usually by validating certain focus states. Personally, I like to use Jest and React Testing Library, but again, use whatever works for you. We're really just focusing on the strategies of how we want to write this test and what we want to focus on. Let's start off with a really simple component. Here I have my accessible button, and I'm going to pass in a prop called accessible label. And I want to make sure that I'm conditionally rendering my ARIA-label attribute based on whether or not the accessible label prop is present. And aria-label provides a label for this element it's applied to so that something like a screen reader can come in and know that it should announce this label to our user. Now let's step through what I could test for this component. To start off, let's make sure that we're only rendering aria-label if our accessible, let's test that we're not rendering aria-label if accessible label is not passed. We're going to construct our accessible label button and then render out the accessible button component and grab a reference to that component by my test ID. And here's what we really care about. I'm gonna add an assertion that says, I expect my rendered button not to have an aria-label because I did not pass an accessible label to it. We also want to make sure that we're testing the opposite case for this. So when we do pass an accessible label to this, I want to make sure that my aria-label attribute is rendered on this component. And I can do that by asserting that I expect my rendered button to have the attribute aria-label, and that attribute should be equal to the value that I pass to my accessible label property. Let's set up another kind of test for this, but this time we want to check our ability to focus. Testing that our components can gain focus is a really good way to know whether or not our components can support keyboard navigation. All of our interactive elements and components need to support keyboard-only users, and only elements and components that can be focused or can support focus are going to be able to interact with the keyboard. So I'm going to do pretty much the same setup, but now I want to call the focus method on my rendered button. And then I want to create an assertion that says, I expect this rendered button to now have focus because I mocked a focus event on it. And this test is going to protect us in the future from introducing bugs that might break keyboard navigation. By default, HTML buttons support keyboard navigation and focus, but let's say somewhere down the line, someone comes in and changes our button to a div. Divs by default are not focusable elements. That's because they're not interactive, which means they will not support our keyboard navigation out of the box. But because I've written a test to make sure that I am able to support focus in my components, now this test is going to fail and let us know that we've likely introduced some kind of bug in our code that breaks keyboard navigation for the users. And these are the kinds of things that we want to make sure that we're testing for. We want to find those cases in our components that distills down exactly what the outcomes look like through an accessible lens. If I have a component that's interactive, I need to know how I can check to make sure that it can gain focus and therefore make sure that it can support keyboard navigation. Or I want to consider when my components rely on some kind of ARIA attributes, figure out how I can validate those attributes, whether or not they're present, whether or not they're set, and what their values are depending on different props. And a lot of what we just covered in unit tests can also be applied to our integration tests, except this time we're less concerned about the component APIs and really want to focus on the outcomes of how those components come together. We can still test our ARIA attributes and keyboard navigation, except now it's within the context of multiple components interacting with each other. Back to my Use React website. Let's take this as an example. We have a Slack sign-up form where we can submit an email address and a user will receive an invitation to our Slack channel. When I focus into the email input and then blur out of the email input, some kind of validation method is run. And if there is no valid email in the input, I want to add some kind of red outline to that input to signal that my user still needs to add some kind of valid email address. But I also have to make sure that screen reader users are notified of this error somehow, because right now, this is just a visual indication. We need to make sure that non-sighted users are able to understand that there was an error on this page as well. And that's exactly what we're going to test. We're going to make sure that my error signals for assistive technologies works reliably. So let's take a look at this component. It's called Slack signup container. And we can see there are a couple of different smaller components that come together to build up this container component. We have an accessible input, and it accepts an on blur prop that is equal to a method called validate email address. And based on whether or not an email address is valid, we're going to pass that to our accessible alert component so that our alert can know whether or not it should be handling this message and let our users know that there is some kind of error on the page. And here's that accessible alert component. We can see it's visually hidden because again, this is only a component that's going to be handling the assistive technology side of things, something like screen readers. And we have a paragraph element that has the ARIA role attribute set to alert. And this is what's going to signal to my screen readers that when there's a change in this paragraph node, I need to be able to alert my user of that change and read out that message. And the message is going to be the error once my input is blurred and there isn't a valid email address. So here's how we could test our Slack signup container to make sure all of that works as expected. I'm going to test whether or not our visibly hidden alert is going to render a message when our input blurs without a valid email address. The setup is about the same. I'm just going to render my Slack signup container, query for my input and my alert components, and then set up the test that I want to validate. Here we see I'm going to take my input component and I'm going to run the focus method on it. And then I'm going to have an assertion that says, I expect my rendered alert component not to have any text content. And that means that that paragraph tag in our accessible alert component should still be empty. Because again, we only want to add a message to that component if there is an invalid email address when I blur out of my input component. And that's what we'll test here. Now I'm going to blur out of my input and set an assertion that says, I now expect my rendered alert to have the text content equal to the error message that I passed into my Slack signup container. This is a lot of moving parts, but the guiding principles pretty much remain the same. We're checking that our components still manage ARIA and ARIA attributes correctly. And if we wanted to do something like keyboard navigation, we would want to keep that in mind as well. Now let's talk about our end-to-end tests. And these are the tests that are going to be the closest to how a user would experience our website. We can use these tests to evaluate pretty much the same things as our user and integration tests, but now we're going to do it within the context of fully fleshed out user flows, pages, or entire applications. And I'm going to use Cypress.io for my end-to-end testing. I like it because it's great for browser-driven testing and it has really good accessibility support. But again, you can use whatever tool speaks to you and works for you. One thing to note if you are using Cypress is there is a plugin called Cypress Axe. It's also powered by the Axe Core API. And similar to Lighthouse and React Axe, it checks for accessibility errors and lets you know where you can improve. But now it does it inside your testing suites. So you can keep all of the same validation in the same place, and it allows you to easily integrate into your CI/CD pipeline. So let's see how we can write a very simple end-to-end test using the Use React NYC website again. On this website, we have a section where we show all the images of the organizers. And in order for this section to be accessible, I need all of my images to have the alt text attribute set. And this is for screen reader support so that our screen reader can announce to the user what this is an image of. So we're gonna check to make sure that my page renders in the browser and all of our organizers have the alt text set. We're gonna use Cypress to query for all of the organizer images. And then we're going to map through those images that we get back and set all of our, and get all of our alternative text attributes and place them into an alt values const. And then here's where my assertion comes in. I want to make sure that all of my alt values are equal to the length of organizers that I queried for. And this is going to make sure that I have non-empty alternative text values equal to the amount of images that I have. Now, for the sake of time, this is a really oversimplified test, but what's important here is getting to the root of how a user would flow through our website and translating that into a test. So for a screen reader user, that would mean I have 5 image elements and I need to know I need to know all 5 of these, I need to know what all 5 of these image elements are. And I can do that programmatically by checking what the alternative text values are. So when we're writing out a full suite of accessibility end-to-end tests, we can ask ourselves things like, what should happen when I successfully submit my Slack signup form? What are the ARIA attributes and where does that focus go in relation to how a user would interact with this on a browser in the web page? Or we can ask ourselves, what happens when a user navigates to a different page in a single page application? What do we expect the outcome is when we click on a link? What are the implications for accessibility support? And what happens to the keyboard focus when we perform those actions? And that just about brings me to the end of this talk. So let's really quickly do a recap. We talked about tooling and how certain tools help prevent accessibility bugs from being introduced in our code while we're writing code, when we are committing to different code bases, and when we're shipping to production. We also talked about testing. We covered unit, integration, and end-to-end tests. We talked about when we would use which, what to test for each category, and made sure that we were thinking about these tests in relation to how the user is going to be interacting with our components and our websites. Now, that was quite a lot to cover in the amount of time that we have. And there's still plenty to learn while you're creating your own accessibility development workflow that's going to work for yourself and for your team. But if there's one piece of advice that I want to leave you with, it's this. I know that it can be really overwhelming if this is the first time that you've thought about accessibility in relation to your app, and you're just now taking stock of all of the work that it's going to take to bring it up to standards. But it's absolutely not expected that you have a fully accessible site or 100% test coverage on day one, the day after you started talking about it. Make incremental changes where you can and consistently chisel away at the accessibility errors. Eventually, implementing those small changes are gonna add up to a much deeper understanding of what it's gonna take to make your website accessible and how to make it resilient against accessibility bugs. And once we have that understanding and have our automation and testing processes in place, it'll be a lot easier to make our websites work for everyone. And that means it'll be easier to build a better web for everyone. Thank you.